Hi, everyone. Thank you for attending the presentation. My name is Jia Zhang. I'm a PhD student at the University of Pennsylvania. Today, I'll be presenting my paper titled Investigating Student Interest and Engagement in Game-Based Learning Environments. This work has been done in collaboration with researchers at UPenn, North Carolina State University, and University of Florida. As suggested in previous literature, interest is a construct that has both cognitive and affective components. For example, when we say a student is interested in learning a subject, the student is not only more likely to enjoy the learning experience, but also it is more likely for them to engage themselves with the subject in the first place. Particularly in science learning, interest motivates students to engage with science content and practices. Interested students are more likely to engage in self-regulated learning, showing increased attention and better goal-setting abilities. So here we can see students with different levels of interest are likely to be associated with different levels of engagement and learning behaviors. However, a more careful attention to the types of interest is needed, as these may be critical for fostering equitable learning outcomes. For example, in Heidi and Renninger 2006, they describe a four-phase model of interest development that distinguished between two phases of situational interest and two phases of individual interest. The first two phases, the two situational interests, are relatively unstable and fleeting, and they are developed and maintained mostly relying on the context of the learning. For example, when students studying an unfamiliar topic, their interest is there, but it's likely to go away once the knowledge gap is filled or their curiosity is fulfilled. So the re-engagement with the topic may not happen. However, on the other hand, the individual interests are more developed and are more likely to maintain and endure regardless of context. Therefore, as learners progress from phase 1 to 4, they become increasingly motivated to re-engage with the topic without needing external support. Conversely, students who have not developed individual interest likely need more extrinsic reward and stimulation to trigger situational interest. And therefore, in our study, we narrowed our focus to situational interest. We wanted to examine how student situational interest in a game-based learning environment is related to student content knowledge, engagement, and learning behaviors. Specifically, in our study, we asked these two questions. First, how is situational interest related to content knowledge? And then the second, how is situational interest related to game completion, which can be viewed as an engagement measure that I will explain in a bit. By having a better understanding of this relationship, we aim to provide insights that will inform the design of adaptive learning system that could personalize rewards and stimulation based on the student's situational interest level to better incentivize their learning. In order to understand this relationship, we first collected log data from Crystal Island, which is a game-based learning environment for middle school students to learn microbiology. In this game, students are placed in a research camp on a remote island and play the role of a medical detective who are tasked to identify a mysterious infectious disease and its transmission source. Students must navigate the island, gather information, form hypotheses, conduct tests, and synthesize their findings to solve the mystery. During this process, students learn knowledge about microbiology through reading books and information they gathered. The mystery is considered solved only when students correctly identify the disease and its transmission source. So, as we mentioned earlier, to solve the mystery, students not only need to have the relevant microbiology knowledge that they have learned along the way, but also they have to be engaged in the game, gathering information and conducting tests in order to solve the mystery. Therefore, we consider solving mystery as a measure that contains both knowledge and engagement components. In total, we collected the following data from 77 middle school students. For these students, we collected the performance on pre and post tests, an identical knowledge assessment that is used to reflect student knowledge level on microbiology. Additionally, we collected the students' log data, which record how they play the game, such as if they have solved the mystery, the number of hypotheses they formed, etc., etc. Lastly, we used user engagement survey, UES, and a revised version of it to evaluate student interest in playing the game. The survey was administered at the end of the study. Of the responses collected from the UES, we specifically look at student scores on the following 3 scales, which are novelty, felt involvement, and focused attention, as we believe these 3 measures are most closely related to the situational interest that we're trying to measure. Specifically, in novelty scale, students are asked about their interest and curiosity in the game. 3 questions are asked and counted toward this scale. For example, on a scale from strongly disagree to strongly agree, students are asked to rate how much they agree with the statement that they continue to play the game out of curiosity, for example. The 3 questions are listed on the right. The felt involvement scale has initially been characterized as capturing the enjoyment and interest of the gameplay experience. In this scale, similarly, 3 questions are asked and counted toward the felt involvement scale. For example, students are asked about how much they agree with statements such as, I was really drawn into the game, or I felt involved in the game. Lastly, we also selected focused attention scale in our study because it measures a flow-like engagement. As a matter of fact, this scale has been shown to be strongly correlated with Jackson and Marsh's flow state scale. And 7 questions are asked in this measure. So in summary, the novelty scale appears to capture a basic measure of situational interest, focused attention capture flow-like engagement, and felt involvement might be described as the enjoyment at the intersection of these 2 constructs. With all this data collected, we first looked at how situational interest is related to content knowledge. To this end, we used Spearman correlation and examined the relationship between student performance on the pre and post test and the 3 interest measures. We found that all 3 measures are positively and significantly correlated to pre-test. Novelty and felt involvement are positively and significantly correlated to the post-test. In this study, which means students with higher knowledge of microbiology showed higher interest in the game. Well, correlation cannot imply causality. This finding is in accordance with prior work, showing a symbiotic relationship between interest and content knowledge. We then moved on to examine the second question of how situational interest is related to game completion. We calculated the average score on the 3 interest measure between students who solved the mystery and who did not solve the mystery. We then ran a t-test to check if the differences is significant. As shown in the bar graph at the bottom right, we find that students who solved the mystery reported higher interest on all 3 measures. In another word, students with high interest were more likely to solve the mystery and thus complete the game. As we mentioned before, game completion speaks both to student knowledge and also to their broader engagement, since post-test measures show improvement even among students who did not complete the game. This finding implies that those with higher interest, in addition to learning more, were more motivated and engaged to complete the objectives of the game. And that is everything we discussed in the paper. There are a few things that we are currently working on and planning to do in future studies. First, in addition to content knowledge and game completion, we're conducting analyses to understand how situational interest is related to in-game learning behaviors. For example, we would like to know if interest students are more likely to engage with NPCs, or if they're more likely to read more books or conduct more tests, etc., etc. Secondly, in future study, would also like to consider other ways to measure interest, aligning them with student behavior in learning systems. For example, in this study, we use retrospective UES scales to measure student interest, but measures designed to capture situational interest in the moment or to capture interest more broadly. For example, the intrinsic motivation inventory might produce different results. And we would like to know if this result would be different, and if so, how. And that is everything. Thank you so much for listening. Would like to thank my collaborators and NSF for making this paper possible. If you have any questions or comments, please feel free to send me an email at joycez@upenn.edu. Thank you.